Remember that average velocity means how far something goes in how much time, displacement per time. V bar, which means average velocity, is equal to delta x, displacement, per time interval, delta t. We can rearrange this to find delta x instead if we are given the average velocity and the duration of the time. Delta x is equal to average velocity times the duration of time. And average velocity is halfway between the initial and final. In other words, final velocity plus initial velocity divided by 2 is the same thing as average velocity if acceleration is constant. So we can use this to calculate the displacement for an interval. Previously, we calculated the displacement for each interval using this equation. Displacement is equal to final position minus initial position. But let's now use these equations, which really are the same thing. It's just two ways of saying the same equation to find out displacement for each of our intervals. So let's look at the first interval. Final velocity for the first interval is 10 meters per second. Initial velocity 0 meters per second. So the average velocity for that interval is 10 meters per second plus 0 meters per second divided by 2. 10 plus 0 is 10. Divide that by 2, 5 meters per second. That's right, we've already seen that that is indeed the case. The average velocity for that interval is 5 meters per second. So to find the displacement for that interval, we multiply that by 1 second. Why 1 second? Because that interval lasts 1 second duration. And that's why the displacement for that interval is 5 meters. For the next interval, the final velocity is 20 meters per second and the initial velocity is 10 meters per second. So we can find the displacement by multiplying the average velocity by the time duration of that interval. We find the average velocity by adding the initial and final and dividing by 2, and then we multiply that by the time duration. So we have delta x is equal to final velocity plus initial velocity over 2 times by delta t. Substitute values into that. 20 plus 10 divided by 2 multiplied by 1. Why 1? Because this is a 1 second duration. It lasts 1 second. So the average velocity is 30 divided by 2, 15 meters per second, and we multiply that by 1 second. 15 meters per second times 1 second. The seconds cancel out. We've got the answer's value is in meters. It's the displacement for that interval, 15 meters. Pause the movie while you complete the remaining gaps. Notice that for each of these intervals, the interval's duration is 1 second long. So delta t in all cases is 1 second. During the third second, final velocity is 30 meters per second, initial 20 meters per second. 30 plus 20 equals 50. We divide that by 2 to get the average velocity for that interval, 25 meters per second. Multiply that average velocity by the time it took for that interval, which is a 1 second duration. It traveled 25 meters during that second. During the fourth interval, final velocity plus initial velocity, 40 plus 30 gives 70 meters per second. We halve that to get the average velocity for that interval, 35 meters per second, and multiply it by how long that interval lasted. Again, a second. 35 meters per second multiplied by a second equals 35 meters. 35 meters is the displacement undergone during that interval. The last interval. How far does it travel in the last interval? Final velocity 50 meters per second plus initial velocity 40 meters per second gives 90 meters per second. We halve that to get the average velocity. 45 meters per second is the average velocity for that interval. The interval lasts a second long, so we multiply 45 meters per second by 1 second and we get 45 meters is the distance traveled in that interval. Let's now rather not just take a second long interval. Let's take the entire time shown here, which is a 5 second long interval. How far does this stone travel in the full 5 seconds? Well, we've already seen it. We know the answer is 125 meters, but let's use this other method to show that. Final velocity is 50 meters per second for this entire interval, and initial is 0. 50 plus 0 gives 50. We halve that, we get 25 meters per second. 25 meters per second is the average velocity for this entire interval. Now we want to find out, using the average velocity and the time of the interval, how far it went during these 5 seconds. So we multiply the average velocity, 25 meters per second, by how long this interval lasts. This interval lasts 5 seconds long. 25 meters per second times 5 seconds is equal to 125 meters. That's how far the stone goes in the whole 5-second duration. Let's take another interval. Let's take interval from t equals 3 seconds to t equals 5 seconds. How far does the stone go during this time? Let's calculate it using this equation. Final velocity for this interval is 50 meters per second. Initial velocity 30 meters per second. So what's the average velocity for that interval? 50 meters per second plus 30 meters per second is 80 meters per second. We halve that. Divide 80 by 2 gives us 40 meters per second. 40 meters per second is the average velocity for this interval. Now to find out how far the stone went in this interval, we must multiply the average velocity, 40 meters per second, by how long this interval lasted, delta t. This interval lasted 2 seconds. How do we know that? Final time was 5 seconds, initial time 3 seconds, so that's 5 minus 3, 2 seconds long. That's how long this interval lasted. So the average velocity was 40 meters per second, and this happened for 2 seconds, and so it traveled 40 meters per second times 2 seconds equals 80 meters. It traveled 80 meters during this time. And we know that that is true because its position at the end of this interval was 125 meters, and the position at the start of this interval was 45 meters. 125 minus 45 gives 80. It traveled 80 meters during this interval.